Welcome everyone to today's SKC Science and Technology webinar series. And I'm Deep Medhi, organizer of this series. Today it's my pleasure to welcome Jeff Rydberg-Cox. I know Jeff for a long time and for almost 20 years, and my colleague at my university. He's a professor in English, did PhD from University of Chicago. He has a very interesting background. One of the few professors of English I knew how to write codes, do programming. So, and he has done a lot of very, very interesting work in the intersection of humanities and computer science. Today, he's going to talk about, how to unlock the mysteries of medieval chant books, using machine learning and multispectral imaging. So with that, Jeff, I'm going to hand it off to you. As I said before, it is going to be more like a fireside chat format. And so, I'm going to stop you once in a while to clarify a few things, especially if it's a Spanish thing that I don't understand, and I know you are an expert in Latin also, so it's going to be very interesting. So with that, take it away.
Okay, well, great. Thanks for having me. Thank you for inviting me to do this. I appreciate it. So what I'm going to be presenting, what I'm talking about today is the the current work of a big research team I'm part of, mostly centered at the University of Missouri, Kansas City. And our bigger focus is trying to understand what's in, how we can use imaging, computational technologies, algorithmic approaches to understand things that are written in books from the 14th, 15th, 16th centuries, and how those books were put together, how they came to take the shape that they have. So that's sort of a bigger frame that we work in. So our work for the last the last 2 years, but we've really been working on this book for probably 5 or 6, has been focused on a chant book that is owned by the University of Missouri, Kansas City Libraries. And we've picked this book because it has a ton of things that are really amenable to, it's interesting in its own right as a book of music, but that it has a bunch of stuff in it that's amenable to study with computational methods too. So what I was thinking I would do is I'd talk a little bit about the book, just give you a sense of what's in it, how it's put together. Then I wanted to talk some about how it's been changed, the way that the book changed over its life. Then talk about how we use imaging to try and figure out how it's been changed. And then I'll get to the machine learning stuff of how we're trying to do this with machine learning rather than with other sorts of processes.
Sounds good.
So, and Professor Maddie, jump in anytime as I'm talking. I'll run through it, but happy to have a conversation as we work our way through it.
Sure. So we want to make it very interactive here. Great. Thank you.
Yes. Okay. So the Chant Book is a book that is gathered together by hand, written by hand. This is before print, and it contains the music that a community of monks or nuns or a church would have used when they were in services. So the book itself is big, so 52 centimeters by 36 centimeters, so a pretty good sized book that's then got mute. So, and what I'm showing here is just a sense of what one of those pages looks like. So the red lines are the musical staves, the black are the notes, the words are the lyrics that would be sung, and then at the major sections they have these decorative capital letters that are sort of aesthetic additions to the book, mark changes of section, changes of song, all sorts of things. But these are scattered throughout the book. Then this book had sort of an active life. It was used regularly as part of church practice, and so people would add things, change things, mix things up as their practice changed. So like what we have here, so this is a medieval piece of music. And then on the right, sometime in the 18th century, someone who was using this book said, boy, we should be able to go to that book and see what's in it. And so someone wrote a table of contents and wrote it on a piece of paper and pasted it into the front. So what it has, oh, yeah.
Yeah, no, that's interesting. So the table of content was obviously not there to start with,
Right.
right? You know,
And,
you don't think about it.
you know,
and by the way,
and we're used
everything
to
was handwritten. Nothing was printed for this particular example, right?
Nothing is printed.
Okay.
All handwritten. And, you know, and when we talk about like a table of contents, when books were in the 15th century, the table of books didn't have tables of contents initially. So it's something that got added to the form of the book later. And so then in the 18th century, someone who was used to opening a book and seeing a table of contents said, boy, we should add one to that older book in some form.
Got it. Got it.
Okay. And so then what it has is that we know that there's music that would be part of sort of the standard church service. And what we know is that there's a series of versions of pieces of the Mass that would have been part of, that would have been performed around Easter. Then there are also other pieces that are inserted around that, so that, so there are pieces of other things that are bound together to make a single book. And it's a series of other kinds of music for other sorts of celebrations or services in the church. So like you can, and then you can see like this looks like it's done by one person in one hand. And then all of these, they look fairly different as they've come from different sources, different people, different groups wrote them, and ultimately they got gathered into this one book. So it's not exactly an anthology, but it's a collection of material from different sources, different places. So that makes it, okay, so the book itself was used in Spain. So inside a book, that it's got ownership markings from 2 different convents and monasteries in this region of Spain. So we think it spent most of its life getting used in a couple of different settings in Spain.
Okay.
So it's primarily an example of a span of what's going on in these churches in a particular place in Spain.
So did you, in this particular one, did you know what particular church or region of Spain?
My colleagues have found these ownership markings and tracked them down. So yes, so they know specifically. So these markings are there to, are just on the page, and then they were able to track down what they referred to. So which library, which church, which monastery, which convent they've said they were from. So yes, so they do. So we do know where it was used now, but on the basis of those markings. But let's talk about then how. So that's the book, big collection of chants, handwritten, used in a couple of different places in Spain over a couple of hundred years or more. But then if we're talking about how it's been changed, what we've got is there's a couple of ways that it's been changed. So this is a particular song for a particular service. And then if you look at it just closely, you've got the main words in the bigger print in the bottom right are the lyric. And then someone else later added in that small word, like a different lyric. So there's 2 different things you could sing to the same tune written into that piece. And so this is something, so this is an example of, this might be, my colleagues who study this, I'm pretty sure will tell us, I could be wrong, but I'm pretty sure they tell us this has happened when it moved from a monastery to a convent. So where it moved from a male house to a female. And so they added new, right? So as the context changed, they used the same melody, but added different words and wrote them in over. Another way that it's been changed, something like this has been changed, is that at various times the style changed, right? Think about, like, if you think of music from the music that you like 20 years ago versus compared to music you like today, it's different, right? Styles changed, tastes changed. There were changes in the culture of the European Church around that led to changes in simplification of the way that music was performed. And so here, what would happen in a book like this is they would simplify. There's some simplification, right? So here, like in the upper, can you see my pointer or?
Let me see. Let me see. I thought, yeah, yep, I do. I did see.
Okay.
Yep.
Okay. So in this upper left, I'm pointing with my pointer. I wanted to make sure everyone else could see it.
Sure.
So like in these green boxes, that shows places where there were notes, and then they were scraped off. So the ink was on the page, and they decided they weren't going to sing. They were going to simplify, and so they took those notes out. Right. So this is places where, in the history of the use of this book, a decision was made to simplify. So notes are taken out here on the left, and words are taken out on the right. And so this is just, again, part of the natural evolving process of the use of the book. And the book, so it's instead of, the book's paper, all of this was expensive. So you don't just go buy a new edition, you update what you've got. So you've got this writing in over, you have simplification, and then you also have annotations. Again, imagine a book that you use a lot for some of your own studies, right? That you'll write notes in the margin, you'll use a tab or a bookmark to keep track of where something is. So that you've got the original music, and then later you've got, like here, a tab that somebody added so they could go to a page they had to go to a lot. Or a little bit of a note about what they're wanting to, about what they're doing with the chant at that point. Then it's paper, right? Any book, think about any book you use a lot. You have your notes in the side. You might drop it in your bag and it gets bent. A page gets torn off, right? And so there are places here, like see around here, where something got damaged and there's another piece of paper laid over to do some sort of repair.
I see.
As
makes sense.
So yeah, so you've got, and then what none of us have ever done, right? You realize you're writing something down, you realize there's a mistake, you're writing it in ink, and you take your pen and you cross it out, right? So there's a whole series of corrections, changes, updates that reflect that this book is a actively used thing, right? It's not something that sits on a shelf that gets taken down, consulted, and put back. It's something that gets taken out, used as part of the religious activities of the groups that own it, but then it gets updated, modified, changed to reflect the ways that they're using it. And so if you're thinking of this from the point of view of the humanities, it's a case study in the ways that music is written and performed. It's a case study in the ways that religious life is organized, right? So there's all sorts of questions that someone who's like who's a historian or someone who's interested in music is very interested in what's going on in this book.
Also, I suspect it's also goes to the stylistic change over time. Things change, as you said, about music. That may be very interesting to know. What has it, hopefully they didn't actually change any of the tunes. I mean, notations. I mean, they deleted it, you said, to simplify, but maybe they did change some tune to just say, okay, it's kind of very interesting.
Right. Well, here's my next one is they did change it.
Yeah.
But what we're getting at, what I'll jump a little bit ahead, is part of our group is working with a team that's very interested in the ways that chant was written and changed. And so they've developed a database and a catalog of all of the variations, all the regional variations of all of these chants across time and space. And then part of what we're doing is seeing if we can, what we are doing is seeing if we can recover the ones that got replaced. So this one, so if you look at a page, you can see how kind of complicated a page can become. So over here in the corner, a colleague who used to be with us at University of Missouri, Kansas City, and is now in Stony Brook, noticed this name, E. Strozzi. And so Strozzi is a name that's known in a lot of contexts from this period. But what we've determined is that this is a piece of music that's somehow associated with Strozzi, where what they did was they scraped off notes here and added new lyrics. So there's both, so there was something else here. Like you can sort of see the ghosts of the old notes. And if you look the ghosts of the old words under the existing words. So what we have is, it's as a palimpsest where you've got something that was written, it was scraped off, and something entirely new written over it.
Very interesting. Yep. I mean, that seems like, all of these are plausible when you think about it over a period of, a few hundred years. So
a few hundred years. And then
right.
places where we'll get to this, we'll spend a lot of time with this page, because instead of having it something being scraped off and something being written over, they scraped it off, but then nothing was added.
Okay.
So they didn't,
I see.
Presumably, they didn't need the space. So we actually have so in this book, we have a page where we know where there was something that's no longer there. So does that make sense for kind of what the book is, and then what we're sort of trying to look at inside of it, how it's been changed, what we're trying to figure out?
Yep, it makes sense.
Okay,
go ahead. Yep.
And then this is the when we say how can we unlock the mysteries? These are the mysteries, right? What are the notes? What are the words? How was it changed? When was it changed? Those are the things we're trying to. Those are the questions we're trying to answer. Okay, so the ways that most people who do this kind of work do this work is with multispectral imaging. And so what that usually means is you have a system that can capture that. It takes an image of the page and separates out the different frequencies of light into separate images. So what we're showing here is we have a device that has a sensor, and then it has a box with a rotating filter wheel that only allows through specific frequencies of light, so that we illuminate the page with full frequency. Then as the light reflects off of it into the sensor, it goes through this filter, and we only capture the specific frequency. Then an Arduino controller rotates the filter. Then we do it again. We capture another that wheel has, I should know this, I want to say 13 or 15 filters in it.
Wow.
There's other ways that you can do this. Other cameras where it takes one image and separates them out. One of the challenges that we've faced is that those cameras generally are expensive, in the neighborhood of $100,000. And we, in our institution, didn't have that kind of money to buy a system like that. Most libraries that own this kind of material don't have the expertise to build that kind of system. So we've tried to are working on building one ourselves. Right. So this is something that we have built together with it. When all is said and done, we probably spent about $4,000, $5,000 on it. Okay. So
it has to be custom made, basically. There's nothing like this anywhere, pretty much.
There is stuff like this. It's just it's more expensive than is feasible for most institutions of our size to access.
Okay, got it.
But one of the things that we're doing is comparing this system to other kinds of equipment. So we'll get into can we do this with machine learning with an RGB image is ultimately where we're going with this.
I see,
and then also you don't have to buy something like this, right? Like most scientific instruments, you can rent them. And so one of the things we're going to do is we've got our home built system, we've got our machine learning algorithm that I'll talk about, and then we're going to validate them both against a rented one to see if, against a commercially available one that we don't have to invest the huge amount of money in it to own it. We can get it and use it for a while.
Got it.
But this is something that we built ourselves to try to see if we could find a way to capture this kind of imagery without needing to invest $100,000. And so if people have not seen multispectral, multispectral imagery. Light is divided in nanometers from across the visible spectrum. And so as we go through, this light reflects off, goes through the filter, and we capture it at the different wavelengths. And then you end up with a series of images that are separate or can be combined into a stack that lets you look at what you can see under each frequency of light. So if you just step through at 400, you don't see a whole lot. Different things become visible as you move through the spectrum, as you move through the visible light spectrum. Then what you try and do is you use a series. There are different ways you can process these images. There's an open source package called ImageJ that lets you do some of these transformations. There's Python packages that let you do this. But fundamentally what you're trying to do is put the different wavelengths together in ways that let you identify things that are visible in some frequencies that are either obscured or not, or blended together. So you're trying to increase the contrast and make the things that are hidden emerge and become visible. The one that I've been spending the most time with is image division, where you effectively take something from the 700 range of the image and divide by something from the 400 range. And then you adjust the histogram to make so that you can see the pixel, so that when you do that initial division, it's pretty black. And then you adjust the histogram to focus on the peak of the histogram, and it makes some of that hidden text emerge. So, but what you can find when you do this sort of work, so this is something that one of our graduate students put together a whole bunch of things and said, if you look at the reds, right, that here, see how it responds differently in this false color image, that suggests different reds, that someone at some point changed the red, right? That the number 2 indicates notes that you can't see on the visible page. 3 indicates a note that's on the back, right? If you think about a page and you're holding up to the light, right, you can see what's on the other side.
That's right.
So as you're doing this work, you have to think about what's obscured or scraped on the page I'm looking at, but what's on the other side,
right?
Too. Am I just seeing something from the back, or am I seeing something else?
Yeah, especially if you do spectral imaging, you need to filter out anything from the back to start with.
Right. Yeah. That's right.
You don't want that to be included eventually. So processing point.
Right. You don't want to be saying, oh, I found hidden text, and what you found is just what's on the other side of the page.
Correct. Right. That's another challenge there. So.
Right. And so for the blue, and again, this is a false color image.
Jeff. Did you ever take physics or chemistry back in high school or college?
I didn't. Okay. I wanted to take physics because they wouldn't let me because I had to take gym, physical education.
I see. Okay, very interesting. Okay.
So I wish I had.
Okay. We always think, we needed to take more stuff than we ever did in school, Right. We don't realize until later. Go ahead, please. Yeah.
Right. But of course you don't realize that, who knew that. This goes back to what I'll get to at the end, the amount of, right, you need someone who knows music, you need someone who knows book history, you need someone who knows computing, you need right. It's a big team that you need to, or a big set of knowledge that you need to understand a book like this. So let's see. So 4 is places where is evidence where you can see the scraping marks. So it gives us a sense of where it was corrected. And 5 is a missing letter. Right. So that's the sorts of things that we're interested in finding, that we can find with multispectral imaging. Okay, so then if you apply this to a whole page, this is that page I was talking about where it's been scraped and nothing was added. So this is one image process lets you just see places that have been corrected, right? So it gives you a better sense of some of what's going on in the corrections, and places that you want to look for corrections. If you do this process differently, you're processing the data differently, but instead of instead of finding the place, you're still seeing the places that are corrected, but what you're doing is getting increased contrast that actually lets you read the words.
I see.
Right.
Okay,
So
got it.
this is this. And so what we're able to do is then so we've take the multispectral stack. This I've been doing with image division, and then histogram adjustment to find, and that when you do that histogram adjustment, this hidden text appears.
Okay.
Got
it.
So you have that piece. Another thing you can do is isolate those colors, because one of a question that a humanist might be interested in is it looks red to the human eye, but how many reds are there? How many inks, how many reds or how many blacks are on this page, which indicate correction or a different hand, it being edited at a different time. And so this is just showing the isolation of the red. But one of the things one of our graduate students is working on now is trying to do color clustering.
Okay.
And using color clustering to determine how many inks are on a page.
Correct.
And so the challenge is, if you run a k-means clustering on this page, you get there's brown for the page, there's a red, there's a couple of blacks. And so what we're trying to figure out is there enough data to move from what the computer sees as distinctions of color to what a humanist understands is a distinction of ink.
Correct. So another way to put it, Jeff, is that if we are able to process it, as accurately as possible, the result is of value to multiple different type of scholars, in fields, basically. That's the other output of this sort of a work, basically, because some people are interested in the music itself, some, changes in what happens with the time, all kinds of stuff, right? So.
Right. And I think that, underneath it, the algorithms we're using and improving and enhancing then are also broadly applicable in other fields of computer vision too, right? That there are ways that Dr. Lee or, that as they're working on this, that they can see this informing work that they're doing in completely unrelated fields, not in the humanities. Right, so so the algorithms are improved and then become more useful far beyond the case study of the Chant Book. Okay, then here's my example of where what we can find is bleed through. Okay, so this is the page we've been looking at. This is multispectral imagery. This is the other side of that page. So see, like this area that's highlighted in red, that is the backside coming through. So just an example of how when we do this imagery, we're having to distinguish between what's scraped and obscured and what is just from the other side.
I think that's especially important for letters, I guess it can get flipped. So you can sort of figure out, but for music, you don't know.
They're just boxes.
You don't know, boxes, right? Correct.
Yes, yeah, so if you flip a square, it's still a square, right? Okay, and so then what this leads to for us is that then the musicologists then know that this is a chant that we didn't know, we know existed in some way, but didn't exist exactly in this form. So this is a new variant of a chant, of a song that didn't exist that we didn't know existed in other forms. So again, you're learning things about music, you're finding stuff in this book that's not just, sometimes you're finding, oh, this is a version we already knew about. Sometimes you're finding small variations. Sometimes you're finding bigger variations in the way in the way this music was recorded, written, and sung. And so part of our team, and that I have met with and talked to, but I'm not engaged with, is working with this group called Cantus, and that their scholarly focus is understanding and inventorying and cataloging these chants and the way these chants are very, very across space and time in different chant books and in different places. So we're taking all of our work integrating it into this international database of this music. So as we find this music and understand what it is, it gets added to the base of knowledge about what this is and what our version of these things are, so that then somebody who's coming in and interested in the music can find it and connect it to all the other versions of the chant or different chants that are in different libraries in Europe or in the United States, or wherever they happen to be held. And so sort of a completely separate project that we connect with to take the information we're learning about this book and add it to a global store of knowledge in another field. Okay, so that's the book, what we found, what we're doing with it. So now the last bit of this is to talk about kind of the current research that we're doing. And so the current work is to say, what if we could get enough data out of an RGB image to do the same sort of work we were doing with that hyperspectral stack, to do these same sorts of investigations. So you go from needing a specialized piece of equipment or an expensive piece of equipment or a rental piece of equipment to being able to go to a library, take a picture with your phone, and do some of this processing.
Okay.
So what we've been
couple
doing
of questions here, Jeff.
Yes.
Most people know what RGB is. You wanted to say what RGB is still.
Oh, RGB. Okay. So
I know
RGB
is
yeah. Right. Is, when you capture an image with a standard camera, it captures light in three frequencies, a red, a green, and a blue. And so then when you look at it, when you look at a color picture on your computer screen, it is a combination of the red, the green, and the blue being mixed together to build all the colors that you see. So it's how computers store image data.
Correct.
Is that fair enough? Does it show that I didn't take physics?
You did a great job. So
yeah, but it is that basically it's a way of saying it's capturing that it's the standard data that every digital camera uses, or most digital cameras use, right? So can we use something that you capture with a normal camera to do this kind of investigation? And so what we're working on, or what we've been working on, is our colleagues in computer science for other work not related to the books developed the process of superspectral resolution that takes the three channels, the three sets of data, the red, the green, and the blue, and trains them in a deep learning model with training data that of a multispectral stack like I showed, and then uses that to predict what the pixel value would be at each specific frequency. Does that make sense?
Yeah. Mm-hmm. Right.
Okay.
Exactly.
So, when we started doing this, there's an image data set called the CAVE Multispectral Image Database, and it's a database of everyday objects that they've taken multispectral images of, and so then you can use that to train the model. So what we did initially was built a model, a machine learning model, trained it against this CAVE data, and then processed our images with it. What we found is that if you're taking pictures of spoons and forks and tables and chairs, that doesn't give you very good prediction value of what's happening on a page. So what we did was, there is a group that has done high quality multispectral imaging of an 8th century gospel that's at Lichfield Cathedral. And so they went in with a multispectral camera, did all the multispectral imaging, did the same sorts, they're trying to do the same sorts of investigations that I was showing you that we're trying to do in our Chant book. But then what they did, they made all of their data available open source under a Creative Commons license. So we were able to go to this lichtfield.ou.edu, download all of their multispectral imagery from their pages, and retrain our model using multispectral images from a book. And what we found is that when we trained off of a book, that then we were able to get 85, the model was able to generate 85 to 95% of the data that was in the true multispectral image.
I see.
So our process here was we built the...
Yeah, let me rephrase it. So you got the multispectral imaging that is done with the equipment that you kind of custom built there. But you wanted to go to a simpler process with, taking an RGB image, as you said, and then do machine learning to see how good we are with this simple way to do it compared to multispectral imaging that has been done. Is that a fair assessment? Right. Okay.
And so that if you take, and when you do the assessment, we're at this, what I was saying, 85 to 95% of the data. So what we have here is what we predicted a 700 nanometer image would look like based on from an RGB image in our model. The actual image, the actual 700 nanometer image of the same thing, and the difference. And so at 85 to 95%, the question that we're working on now is this good enough to do the sorts of investigations that we can do with the multispectral imaging? Does this simpler process give us good enough data?
Correct.
To do the sorts of to answer the sorts of questions that we're trying to.
So Jeff, is the code, there's a question here, is the code using in Python, or is it something else?
The code is in Python. The code, we're writing all the code in Jupyter notebooks.
And Jupyter notebook, fantastic. Okay.
Yeah, so which library do we use in Python? Is it Torch?
It's mostly coming out of TensorFlow. That they're doing this training.
TensorFlow. Okay. Thank you.
Yeah. And when we train the model, we have to run it on a GPU. We have a gaming GPU with a Thunderbolt port that was plugged into a standard computer. And then when we run we can run the model. We could actually run the model on small images in Google Colab.
Okay.
We're having some issues with memory overflow as we get to bigger issues. So right now we're playing with, does Google Colab, if we plug it into a dedicated GPU or use Google Colab Pro or tile the images, some way to process bigger images. But it's all being trained in Jupyter notebooks, and then share it in Google Colab.
So no, that's fantastic. So usually, how long does it take it to run it? I guess for just to train or
to process.
To both of them. So let's say, just to kind of get.
So the training was about 72 hours to build the training data, but we were using a single. And
that's on a GPU machine, right? One GPU machine.
That was on a GPU machine, and so that was on a standard Intel machine with a GPU with an NVIDIA gaming GPU plugged into a Thunderbolt port.
So
so a faster GPU would be faster.
You don't really need a supercomputer. I mean, that was a question. So it's just
no.
I mean, if you have a supercomputer, your training time will come down from 72 hours to something small.
Right. And then I think on the other side, we've got.
You are willing to
run
it on the cloud. You could probably cut down. As long as you're
right.
To pay for it. Got it. Yep.
Right. And that's where and then on the processing side, the limiting factor is memory. More than what
I see.
So we have to scale the images down to process them, but they process in less than 5 minutes.
Okay, got it.
The challenge that we have now is that when we downsample the images, you can see that hidden text, but it's not fully legible. And so we're playing. So the question that we're literally working on today is, should we tile the images and restitch them back together, or should we move to which would let us work with arbitrarily large images, or should we try it on just to keep trying it on a bit, like where we don't know where our memory limit is. We're at 11 gigabytes wasn't enough.
Okay.
So
So I guess it's a very interesting. So let me recap that part of it. It looks like a very interesting trade-off question, because if you have ideally, if you have the best resolution image, with your fancy iPhone Pro, 13 Pro,
Right.
or whatever, right? So you would definitely get a better result if you do the, from a machine learning point of view, or whatever algorithmic thing. But image itself, at least at this point, sort of has a cost, and the cost comes in the form of memory needed on a computer. So
it seems to
you
be
have
memory
more. So you have to basically reduce the resolution of the image. But when you reduce it, you lose some information. So
right.
in a sense, there's a very interesting trade-off going on, that what amount of reducing the resolution you can still live with, but still get very good result. That's the
right.
Intellectual.
That is the trade-off.
Yep, that's the intellectual
right.
question. Okay.
And then the related question on the humanities side is that there's, in the United States, there's this a set of standards called the Federal Agency Digitization Guidelines Initiative.
Okay.
And they specify for really rare, really fragile, really valuable stuffs, their specifications, you end up with images that are 100 megapixels. So fancier than an iPhone. So if you're thinking about like Google Arts and Culture, where you can go in on the super zoom on an image.
Mm-hmm.
And so that's sort of the top end of that trade-off, right? We certainly probably don't need to process images at that resolution, but we need to be able to take them on the input side and know how far to downsample them. Right.
Mm-hmm. Very interesting.
Yeah.
Very, very interesting. And obviously, I mean, you can still do in a very high resolution, but not with a standard computer. Some other place.
Right.
To do it.
Right. And again, that goes to the trade-off of what do you want to be able to do on your laptop, or what do you want a normal kind of a normally equipped library or computer, humanities scholar to be able to do, versus what do you need more computationally intensive resources for?
So there's a very interesting question here on the chat, which is that do you have a way to know what part of the resolution is lost? When you say, assuming you have one computer with 64 gig memory or whatever, you run it, and then another one you run it because you have only 11 gig resolution. Do you have a quantitative way to know, for example, what's lost, or information oriented way to know what's lost in terms of, or maybe you have not done that research yet, but
no, actually, I'm going to write that down. It's a good question, and it relates to a question. Let me pop forward. Okay, so can I highlight this? Oh, sorry, I'm not. This bullet point.
Which one? The third one?
Number 3.
Okay.
What the question you're asking is related to bullet point 3.
Right.
Okay, so because a standard camera doesn't capture infrared, right? There's a filter and it filters out the high and the low. And so our model interpolates that data, but we want to know, I don't know if we know that it's accurate, right? Because it's not there, right? You're generating data, you're interpolating a value of a data that's beyond what's in your data set.
Got it.
And so to really rigorously and quantitatively analyze, like when we're saying 85 to 95%, is that true outside of the visible frequency? And that question of quantitatively knowing what information you're losing in these downsamplings, I think, is related to that. So to the person who asked that, thank you. I'll put that on our list.
No, that's a fantastic question. Jeff, I want to go back to the spectral imaging thing. So you still have at least some sample of what you collected through spectral imaging directly. So have you, on that image itself, tried to do the machine learning to see if something is still either lost or maybe not properly captured?
Right. So that is the current work.
That's the current work.
Right.
Okay, got it.
That is basic, so that we know what we can generate with machine learning.
Right.
We know that it looks good, and we're like probably the next 18 months, that's what we're doing. Testing, evaluating. Like I said, we've got our own internal multispectral imaging. We're going to rent something and really do the comparisons, the validations, and see. And this is what's we've got funding from the National Endowment for the Humanities. That's what we're doing.
Excellent. So, but it's something a slightly different question that has come up. Can you use the machine learning be used for, say, effects imaging in a healthcare sector? The same sort of idea can apply potentially, right?
I think so. That's where that's where we talk about if this works in this domain, it seems like it has impact beyond,
huge
right?
impact beyond what it is. Correct, right? That's what.
And I will say that
Yeah, I was about to ask that. Yeah, that's the effects. So we're during the COVID time when we process prior authorization, sometimes faxes has to be read, and that's a new project. I'm Dr. Mehdi's sister, and I'm a senior director of healthcare analytics in New Jersey. So this is very interesting machine learning. That's why I asked about the Python.
Very good question.
So this is some project that's coming up. Thank you.
And I can send you. Oh boy, where's the article? This is the.
Okay, that'll be very good. Yep.
Excellent. Thank you, Jeff. So Jeff,
another question: when you said you did histogram, the histograms are based on the pixel size of the.
Yeah. So after you do the image division, what happens is that the image with the thing you see on your screen is basically monochrome. And when you look at the histogram, there's a peak it skews to the left. And so you shorten the histogram, and then that's where, and when around that peak, and that's when it becomes visible. Does that answer your question?
Oh yeah, so it's not skewed.
It's not right. So it's not skewed, and then that allows that to be human readable.
Thank you so much.
And if I could throw in another active research question, there is that at the moment that's a hand process. Where you were eliminating that tail. So you're moving the histogram slider in ImageJ and stopping when you can read the stuff, and figuring out the algorithmic approach to do that is one thing that we're working on, is figuring out automating that step, because right now it's not mechanical. It is based on a human feedback of what you're seeing on the screen, where you shorten up that histogram.
Very good. Okay. Jeff, I got another question. How much of the knowledge of musical notes you want to incorporate in the machine learning algorithm framework? Or have you done any of that so far?
Right now, it's just imaging. It's just visible imaging.
Okay.
Yeah, because the other things I should put these in. I don't have a quick slide of these. The other things we're working on are that for this project is a book that has some handwriting by Galileo in it.
Oh, okay.
And then another one that's basically just scratch paper in the back of a book.
Okay.
Bunch of different hands, bunch of different things. So it's more.
Jeff, that's very interesting, because if depending on the domain knowledge, like a music or something else, or engineering book or whatever, handwritten, you could incorporate a little bit of a domain knowledge to the machine learning framework, to basically maybe improve the accuracy a bit,
Right.
And so that's what. Jeff, actually, I have another very important reason why I'm interested in all of this. I don't think it came to my mind when I was thinking about earlier, and my sister reminded me by text, which is that, I come from Assam, as you know, in India. And so we have this old book called Hasipat that's written in the Ahom King's days, and it seems like some of these things we can use to understand if there are some changes done and things like that, so that would be a very interesting side project to kind of explore at some point. So
right. And can I point to my fourth bullet point here?
Yeah, please go ahead. Sorry, I don't mean to
extending this.
Yeah,
This is extending the discussion.
Okay.
So that book that you're talking about, has it been digitized already?
I do not know enough yet. I don't think it is
I
digitized, but it is probably.
do not think so.
Yeah, I don't think.
Okay.
And it's written in papyrus, like
Yeah.
papyrus paper. Yeah,
Yeah, right,
like the
right.
Egyptians used to
No,
write.
I think there might be some digitization, some images, but I don't know how easily it is available. So we got to find that
Right.
out. So
But yeah, but because one of the things that we talk about as the benefit of this work is that if something's already been photographed, we should be able to process that photograph and do at least a preliminary investigation.
correct. That's
right.
True. So let me find that
Right.
out. Yeah. So I'll find that out.
And the idea is that these documents are old, fragile, one of a kind, irreplaceable.
Correct.
And so before you bring the priceless, the one of a kind damageable paper artifact and subject it to the potential risk of all this imaging, if it's already been photographed, you can say, well, let's look at them. Let's run them through our model, process them, and then have the computer, again, we don't have this yet, but have the computer spit out a score that says, I think there's hidden information on this page.
Correct. That's exactly like,
right. And then,
because yeah. No, sorry. What I was going to say that I won't be surprised, like the way you talk about musical notes, that somebody did edited a little bit, put a new ink. All kinds of things are possible that, at least it'll be interesting to find that out,
right.
if something has changed over time, so.
Right. And we would, and like, I'd love to look at it with you, this specific book with you, but, and fit it in, but if to the extent that this works, that's exactly the sort of work this enables, is someone to pretty easily take a scanned image or a photograph of a book like that and determine if there's been some changes that they might want to study.
Got it. Right. Okay, great. Go ahead. So did we cover the point for all of what you wanted to see? I wanted to make sure.
I think so. I think so, right? This idea that, except the only other piece of that is to say that if it's not just this, it's like, we know this book that we're interested in. Can we find something out? But then to do it at scale, could we do it on a whole library?
Correct.
So
that's where you want to go.
Right. Could we just ingest a whole collection from the Library of Congress?
Correct. Right. Yeah, that would be fantastic. I had one more specific question on the machine learning part of it. That in terms of I think you said about you are using TensorFlow. What are the different sort of machine learning techniques you might be considering that might be applicable in this particular space?
And this is where you've hit the limits of my knowledge. Dr. Lee and his students have done this, and I am the grateful user of them. So I specifically, I don't know, except that it's in kind of the stuff that they've already published here, that I can send you the full reference.
Okay. All right. Sorry, yeah.
And you also mentioned about gaming clustering. So I think that's a good algorithm for clustering. You mentioned about that.
Yeah. Yes. That's for that ink identification.
That's only for ink identification.
For the ink.
That's only for ink identification. Yeah.
There's so many. Okay, so go ahead. You wanted to tell about the team, I guess, the big team.
Yeah, so I just go back to the end and say, that when, that as we do all this work, just to make sure that I think we've seen the number of people the numbers of domain knowledge that have to come into all of this, but just to make sure that, there's English graduate students, there's computer science graduate students, there's undergraduates, there's graduate students in musicology, there's professors in musicology. It's a big group and a big set of domains that come into play to figure out all of this, to do this sort of investigation.
This is very interesting multidisciplinary work, very, very important piece of work. So I do have a question about this is my lack of knowledge in chemistry. So Nathan Euler is helping in the chemistry. So what aspect is he trying to understand about the ink that changed, or what sort of things is he exploring in this particular?
Yeah. So and in this particular thing, what he's helping, we're talking about the ink and understanding like if what we're finding in the visible imaging is part of it reflects something that's actually happening in the ink, or if it's just variation in light,
I see.
on the page.
I see. I see.
Right. So the computer can detect differences in the ink, but what you don't know is it can detect differences in the visible, but what you don't know is it just detecting differences in the image, or is it detecting something that's reflected in the physical property of the page? And then more broadly, he comes in on some of the bigger questions that I mentioned, I think before we started, that there's another piece of this project where you're using XRF to see if we can find stuff like what's behind that table of contents, right? What's behind the bindings, what's behind, so to use some of that. And then also he's doing some stuff with Raman, some different sorts of reflectance things, to talk about some of the other pieces of what we can find. So that's where that's the expertise he brings to the group. And then he's also the one who knows, he actually is the one who built the imaging system. So the filter wheel that I talked about, right?
Okay, got it.
So he's got the expertise in, in building sensors, building sensors, take that, all that sort of stuff. So he and Jesse Lowe here. This is Nathan and Jesse, and then there's the imaging machine.
That's pretty cool, actually. That's very interesting. Yep. So
yeah.
All right. Let's see. Jeff, I'm going to open the floor to others who wanted to ask any questions. You may unmute yourself. You have a question for Dr. Rydberg-Cox. All right. Anybody have any other questions? There must be some question from some people.
Can you tell us who is involved with the TensorFlow Python program?
Yeah, so Dr. Zhu Li is the one who, it's his graduate students in his lab that developed this algorithm.
Yeah.
And so that article that I'll send you, it's his lab, and he that work was done prior to this project. And so what had, in conversations around UMKC, as we're working on this, we were connected. And we said, we've got this problem that we're trying to explore. We'd already built the multispectral imaging piece, like the physical, the rig with the filter wheels. And we were connected to him and started to wonder if his algorithm would apply to what we were doing. So it's the work out of his lab that we're applying for the machine learning piece of the puzzle.
Beautiful interdisciplinary.
Yeah,
and I am sure your liberal arts background,
yes.
Science is always the art.
Classics.
The art. And hopefully you can revive some of our old writings from Assam, like Deep said, we'll get in touch with him.
I would love to look at
that. So Jeff will talk offline about it, but there are a couple of questions here on the chat. Let me go to that. One question, I think it's actually a research question, I still believe. Is it possible to find out what resolution is lost if we know the exact point coordinate of each part? Means, is it possible if a graphical aspect is used? I believe it is still a research question that's not quite fully, explored yet.
Right.
So, but I'll let you answer that question.
And I think that's exactly right, that we're in that is that evaluation stage. Like what, and where are we losing data? When some people, we explain this process to some people and they're very skeptical because they feel like we're generating something out of nothing, right? That we're generating something that, we're taking data that doesn't exist to generate. So they don't believe the data exists.
Right.
Right. They don't trust the model.
Right.
Because it's, we're capturing one set of data and saying making another data. We're capturing one data set and making a different data set. And so all of those questions about, where are we losing data? That is the work of the next 18 months. Then the other question is,
go ahead.
Oh, can I,
go ahead.
What's the better answer to this question? And this is maybe for everyone else too, is do we want an algorithmic quantitative answer, or is the answer that got enough data when it's good enough for the humanist to read the missing text.
Correct. That's true.
Right? Do we
Right.
care? I mean, it's interesting to know, but maybe that's the computer science question, but it's not the humanities question.
Correct. Right. So if you can figure it out good enough for that you can figure out the or especially if a music specialist can figure out the rest of it. So this is
Right.
definitely,
and it's that cost, that
yeah.
computational power cost trade-off.
Yep. Very, very good question. I have one other question going back to your initial training part of it. So how do you know that there's no bias in the training part? Do you know anything at this point?
What do you mean by bias?
But is there some bias in the input data to start with because of the way, I mean, what I'm saying, you're taking some images there that could have some bias some way. We don't know the answer to that
Right.
at this point.
Okay, right.
Can that actually influence the training model? That's what I was trying to get to.
And I think the answer is yes, because when we trained using the cave data, we didn't get very good results on the book. So we had to train on a book to get good results on a book.
I see. Got it. Okay.
Right. Right. So that suggests that there's something that the model doesn't generally interpolate hyperspectral. It's not generally applicable without training data from the domain that you're trying to analyze.
Right.
Right. Does that answer the question?
No, that's sort of what I suspected, but I wanted to hear from you because you have done the work in this space.
Yeah. And so you can't turn a camera into you can't turn an RGB image into a general multispectral imager.
Exactly.
You have to have a training set that's related to the questions you're trying to answer.
Right. Very good. One last question here, chat box, is that could you provide us with any reference or link that somebody can follow your work? Do you have a web page yet running?
Yeah, we do. And it's emerging. Let me.
You want to type it in the chat box? That's also copy and paste it there. That might be useful.
Let me. There we go. So it's, and then here I'm going to share. Let me share a different. And then if you go in here, here's our lab projects, and then here's the Chant Book. And so a lot of what we're doing now, so as I'm talking about the current research, is that we have a specific list of pages that we're moving through in order, where we have a specific list of questions that we want to try and get to.
Great.
And so on that web page that I just put out right now, it's just sort of the base boilerplate.
Right.
But as we move through this series of pages over the next 18 months, we're going to add a page. And what we have that's not quite ready for public consumption is a series of viewers where you have an image and then you choose what you want as an overlay that you can use either as a slider between the two versions. So you can have like RGB and then have we can either have a slider or a magnifier that then allows you to look at a region and see it in context and then place over and overlay the other image. So like if we have a image division that shows good hidden text, you can have the RGB image so you can see what's there and then mouse over with this magnifier and it shows that divided image so that a scholar can compare the two. And so that'll be, and it's there and it's in the kind of workspace.
Okay.
So we're buttoning that down. And so that will emerge as as we're doing all this work, we'll be doing the evaluations and then doing this public presentation and talking about some of those specific problems, what we found, what they look like.
Great. All right, Jeff, I think that this is very interesting and thank you so much. I
Well,
don't think I have any other question.
well, thank you, everyone. Thank you for inviting me. I appreciate all the questions. I've got all sorts of it's the best kind of presentation. I have all sorts of new things to go and explore for the rest of my morning.
Thank you.
Yes.
Have a good day.
So your question, I'm actually Gayatri Sharma from Guwahati, Assam. I actually was pondering over your question, the one that you put forward in front of the entire group on how.
Uh-oh, we just lost her.
Gayatri, we lost you. Can you repeat it?
Yes, sir, I'm there. Actually, I was pondering over the question that sir put forward in front of the entire group of like, is the computational power a trade-off between the humanist thing and like, how do we correlate that? So I think I may be wrong, but I feel that if we open it up to like people from both computer science and humanities view, like people working on things that like from literature or people working on things that don't really have that much of a coding or technical background, like people who don't really understand most of the machine learning algorithms going on, who just look at it from the perspective of just see it for what it is and not just understand like how we go about the training or things like that. It brings a different point of view. And if we open source the entire project, we actually get people from all around the world to contribute to it. And it opens up a whole new perspective to it. So for me, I feel it's just a confluence of these two departments. We cannot restrict it to one. We need people from both departments working on it for us to reach a substantial answer to this problem. And it's just not this problem. There are just so many books. Like one of the first things that inspired or just like drew me to this talk was this, that how do we bring these things to like mainstream and like just understanding how machine learning can be used for books and just something that we don't really expect it to work. So like as a student, like a double major student from Assam Engineering College, like I major in mechanical engineering as well as data science. So like to understand how these things work, and thank you, sir. It's like so interesting to just look at it. And yeah, so for me, it's a very interesting question. Like, do we just open it up to both departments and like understand the correlation between them, like how a person from a humanities background looks at it, how a person from computer science background looks at it. From my perspective, I feel that if we open it up to computer science, we can actually have people from all over the world contributing to it, and just the ideas and perspectives of everyone, and just how we can improve our models and how we can go on improving it, and just understanding how it can benefit all of us for like, and just go on beyond one book. It just can be applicable to so many books around the world. So yeah, this is what I look at.
Collaborate through GitHub, probably, right, Dr.
Yes, ma'am. Yes, I look at it like that.
I'm sorry, I missed that piece of it.
GitHub collaboration can be done through GitHub, open source.
Yes. And as you were talking about people who are doing this computer science, data science, and literature, there's a colleague of mine at Berkeley named David Bamman who's doing a lot of this work now too, and where he's specifically talking about using literary texts, that as another source for training machine learning and language generation and information flow. So I'll put him in the chat. When I did my postdoc, he followed me in the same research lab and then has gone on to Berkeley, and he's just doing really interesting stuff that I thought was very related to what Gayatri was saying about confluence.
You make a very good point. Because I was, scared to take physics or chemistry, but my dad forced me to. He said, you have to know basic science. And then I have the statistics, economics, all backgrounds, so liberal arts, and doing natural language processing and data science. Very interesting, keeps the mind busy during this pandemic working on. So I'll follow you and the professor at Berkeley. Interesting, very interesting. Thank you.
Yes, so surely. Like I personally will follow your work as well. Like it's something that I haven't thought machine learning could be used for, and it's like very interesting. And like I've worked on it before. Like I've worked on NLP stuff, like working on tweets and like open sourcing things up. So it's something that I'm very excited about. So don't mind me if I just maybe drop you a mail. It was really a good session.
I would welcome that. And one of the things, like a different project in our lab that we've been working on is using BERT and sentiment analysis, because it's built around
That's what I'm working on.
Okay, but it's built around tweets, right? And Facebook page, 270 characters. Does it work in literary text? And so we just recently published a couple of studies where we did some user evaluations of the BERT sentiment analysis against literary text, and basically said that it seems okay. And so now we're working on like diffusion of sentiment through literary text in Greek tragedy. So a specific.
Oh, you're back to Greek tragedy. I know that was your original work from many.
That's
many
always right. You know that was ultimately my PhD is in classics, right?
Right. I remember that we had many discussions about it over the years.
But again, generalizable.
You can look at the sentiment analysis of Greek tragedies. I guess very interesting, right?
Right.
So,
but more generally, any literary text theoretically should work, right? If you're doing tweets, why not do a novel you love?
Exactly.
Yes,
right.
sir.
What is it changing over, or even you can even think about going farther. Is a writer's style of writing changed over time? That's a very interesting thing. I've been thinking about a couple of writers. When I read their stuff, or even I think about my writing style over last 30 years or so.
Right.
It's like something has changed. I mean, I know, because you learn something. Even in a technical field, what you write, but something changes. Can you capture that with some sort of a machine learning sort of a way to analyze it as like a sentiment analysis type thing? So yeah.
Right. And to think about what are those questions, like that all of our sentiment analysis, they're driven by, can they analyze tweets, but then they're also driven by these questions of, can we keep users engaged? Can we increase revenue? Can we put the right ad in front of the right person at the right time? And so then to think about, and even the people who are doing this commercial, like Amazon, can we detect what a book is about so we can sell it to the right person? But to think about the ways that then they help us understand text as readers, as people who want to read them as part of sort of human experience. As we said, as part of understanding just what makes it a more enriching experience as a reader reading for entertainment, for pleasure, for personal enrichment, instead of, can I sell someone another book that looks just like this one, or make sure they binge my show? Can I detect when the action point is at my show to make sure someone watches the next one?
Right. Yeah, there are a lot of things possible.
Yeah, very interesting.
So it is very interesting.
In fact, the one person that I know from Assam AI, at Assam is our state, and AI is artificial. Shishir Kalita, he was working.
I lost that again.
Yeah, we're losing your voice.
And sentiment analysis. Him.
Okay.
Regarding BERT and sentiment analysis, you made an interesting point. There's somebody in the call. His name is Shishir Kalita, and he's working on BERT and sentiment analysis.
Oh, that's good.
In Assam, but I don't know if you had any questions. He's on I see his name there.
No, that's great.
But we have to do a lot of sentiment analysis. We used to use SAS before, but SAS is very expensive, so it has to go to Python. Yep.
Right.
Thank you.
So what I like about especially, sentiment analysis is not new in itself in that sense, because it is used in, especially in a Twitter verse, a lot of things is done. But what I like is that more thinking in the intersection of different disciplinary things. So, going to your background in Latin studies and stuff like that, trying to kind of hit from a research point of view, product point of view, many things are possible. But research point of view, can you learn about what has changed in literature? Going to my literature, Assamese literature, if I look at it over 100 years, can I see something that is changing in the sentiment way? That's to me, it's a very, very fascinating question, right? How it is written and stuff like that. I know you have done the analysis in the context of, and that's where I feel like the new ways to look at something in a interdisciplinary field like literature and computer science are actually going to be very, very interesting in the next next 100 years probably, so
Right.
I think that's where I think it is, products are products, is fine, but this is really
Right.
where it brings the new set of knowledge that we do not know right now. I mean, it's more like opinion that I read something, I see you're a scholar in Latin because you know that. You said, like, I read this, I read another one, and he said, I think they are different. You can say that
Right.
because I read it and it is just my personal knowledge, and my personal knowledge could be biased to start with, for that matter, right? So that's sort of, and obviously in many cases, like, the ground truth is very important. So you go back to the ground truths, I mean, you do want to go back to the scholars saying that, if you look at a medical imaging related to CT scan, if you want to ask a doctor saying that, I got this, does it make sense from your perspective? You did the image analysis. So ground truth is very important when you think from a research point of view.
Right.
So.
And
Jeff,
one of the
I don't want to take too
oh,
much of your time. I know you got other things to do, but just wanted to, make sure that you're not being constrained on time.
yes.
But I know you wanted to
Yes.
say something. Go ahead and we'll.
Oh, I was just going to say, I think one of the things that when we think about how to read and how it changes what we read is not just, we could talk about change in sentiment, but to think about repetition, right? That according to Ziff's law, when we read, most of the words are the same. And we detect meaning out of the words that change. But, I just read something yesterday that said on any page, 56% of the words are the same. It's the stuff that in natural language processing, we call stop words. But data science lets us, machine learning lets us start to think of, and kind of, some of this lets us think about those things that NLP has ignored because you had to get rid of them because you didn't know how to traditional statistics didn't necessarily address them well enough. And so to think about that data science methods and machine learning methods give us a way to think about repetition and the ways that the words that we see all the time are part of it. So I think that's part of the next big step in what we're doing with, and so I've been reading this book by called Enumerations that came out probably 2016 and he's talking about, that's his opening chapters, is talking about repetition and what repetition means, which I find very interesting.
Great. All right,
So
Jeff.
I actually want to point this thing out
go
to you.
ahead.
Like, do you remember, when we talk about tweets, when we get one thing, like a subject being like constantly being brought up in most of the tweets, like it's called, when we do a word cloud visualization of it, there's like you get that coming out in highlight, like it just pops up in the word cloud. Like it's called like, it's something that's the topic that's being most discussed about. So like when we do, like, isn't it something like something that people are talking about, like the most frequent words are like the things that people are talking about, can't they be visualized by using something like a word cloud or like a graph that just shows on two axes, like the time and the words, the frequency of the words? Like, isn't that something like that? Like we can deploy like models of it. Like LDA is the most common, like traditional classic model, and then we have the NNMF, non-negative matrix factorization. Like we can deploy these two models and just understand the thing for what it is. And then if we go deeper into deep learning and just use transformers with BERT, we actually get better results. Like my project that I'm currently a part of. So like that's something that we were like analyzing and focusing on, how classical models and how the recent developments work and like what's the difference in the results we obtain. So when you just mentioned like the most frequent or recurrent words in some subject, like it be like very easily visualized by using word clouds or something really simple, or like just a graph?
Right.
Yeah, the word cloud thing is that, Gayatri, I mean, the problem is we have done some stuff, but when the word is repeated, as Jeff said, you actually filter it out. But what I believe Jeff is saying is that from a literary context, that particular word might be very important. So, but if it is a repeated, we filter it out. I said, oh gosh, the word network appears too much, we're going to filter it out. And so I think the problem with word cloud is that it's actually biased in many cases because we filter out stuff because of our own interest or disinterest on certain words, right? So when I'm telling somebody I'm projecting some information, but from a scientific point of view, you can actually look at the problem differently, saying that, does it matter what exactly, repetitive word, you want to keep it, because of, so that's sort of thing I think Jeff is going to. So
right, and I think the book, if we're talking about another book that if you're interested in this, there's a guy named John Burroughs a long time ago who did a study of Jane Austen, the British novelist Jane Austen, and classified characters by type based on their use of words like of, he, she, it, her.
I see. Yeah. Okay.
Right. The word that not just, we're not interested in networks that appears too much, but the real stop, like the things we all would say are stop words, right?
Very interesting.
And he said, okay, I'm going to study the stop words.
Yeah, because we want to break it up by part of speech.
Yeah.
Or what we don't need. Word cloud is just for, management project.
Yeah, word cloud
Really
is, you were right. Word cloud
Yeah.
is for management purpose.
Just management, to show them the beginning, the big picture.
Right.
So, I'm teaching an introductory digital humanities class. I'm going to use that word cloud is just for management.
They'll love it. Okay.
Yes.
Yeah, American management, top management, they like to look at it then.
Right.
Okay, all right.
Then
Jeff.
you go deep down. That's what my strategy was, just to get the buy-in.
Right. Yeah. Thanks to my sister and also Gayatri for joining the conversation. And so, Jeff, I think we'll have to let you go. Thank you very much for doing the webinar today. Very illuminating on interdisciplinary, rather multidisciplinary space. So hopefully this gives people ideas on new things to look into. So,
right. And I'll be happy to continue this conversation with you and anyone who participated at any time. So thank you so much.